Hey everyone, and welcome back. Ready to dive deep into LLMs again?
Always.
Well, today we're taking on LLMs and software engineering,
Sounds like a plan.
but not just any LLMs. We're going deep on multi-agent systems.
Multi-agent, huh? Getting fancy.
Well, that's what this paper seems to think. It's all about LLM-based multi-agent systems for software engineering, literature review, vision, and the road ahead.
Okay, so what's the big idea?
Well, you know how everyone's talking about how AI is going to revolutionize software development?
Right.
This paper argues that multi-agent systems are, well, they're the key to that revolution.
Interesting. I'm listening.
So the paper keeps mentioning these LLM-based agents, right?
Okay.
It describes them as having autonomy, perception, even social ability, like they're little developers or something.
I see where you're going with this.
But I gotta admit, I'm a little fuzzy on how that actually works in practice. How does that translate to, building real software?
Okay, yeah, I get that. The multi-agent part is really what we're talking about here.
Right.
Think about all the limitations we always hit in software development. Tight deadlines, crazy complex requirements.
Oh, and don't forget the bugs.
The bugs, of
Yeah.
course. A single LLM, even a really powerful one, it's going to struggle with all of that.
It's like trying to, I don't know, juggle a dozen chainsaws at once. Something's bound to go wrong.
Exactly.
So multi-agent systems, it's basically like splitting up the work, right? Like
Right.
giving different tasks to specialized AI agents.
Exactly. We're talking about leveraging specializations. You have different agents for, say, code generation, testing, even security auditing.
So it's kind of like a well-rounded development team, but made of AI.
Exactly.
Okay, that's starting to click.
Yeah.
But wouldn't that need a ton of coordination? Like, how do these agents actually work together?
Well, think of it this way. Each LLM-based agent has these, let's call them core components.
Okay.
Things like memory, the ability to take action, and this thing they call rethink.
Rethink.
Yeah.
Like when I spent an hour debugging and realized I was missing a semicolon the whole time?
Well, not exactly, but I see what you mean.
Yeah.
So picture this. An agent, it gets information, right, from its environment. It processes that information using its knowledge, its memory of past stuff.
Okay. Think so.
Then it does something. It performs a task that's the action part. But here's the cool part, the rethink bit. It means the agent can look at what it did and be like, did that work? It can take feedback from other agents or just from the outside world.
So it's like they're constantly learning, right? They don't just blindly follow instructions.
Exactly. This constant feedback loop is what makes this so powerful. It's how they adapt and refine things, work better as a team.
Now, that is a dream team.
Right.
The paper mentions these, three big benefits of using these LMA systems: autonomous problem solving, robustness, and scalability. But I gotta be honest, sometimes those benefits, they sound a bit too good to be true.
I hear you.
Do you have any, real-world examples where these benefits are actually, happening?
Sure.
Especially, I'm curious about this debugging thing.
Debugging.
It feels like I spend half my life chasing down those weird errors.
Let's talk Fix Agent.
Fix agent.
Yeah, this framework. It's built specifically for debugging. A great example of how this can really make life easier for developers.
Easier debugging. I'm all ears.
Fix Agent, it goes through your code, finds potential problems, and even suggests fixes. And the best part, it learns as it goes, gets better at finding and fixing bugs over time.
So it's like having an AI pair programmer who just, zaps those bugs away.
You could say that.
Does this mean, human debuggers are out of a job?
Not at all. Human oversight is still key. Think of it as a tool, a really powerful tool, but still just a tool. It helps developers. It doesn't replace them. Humans are still the ones bringing creativity, that big picture thinking.
Okay, that's good to hear.
Yeah.
It still sounds like this could really speed things up, though.
Oh, absolutely.
And the paper, it goes even further. It says these systems can be used, across the entire software development lifecycle, from requirements to maintenance and everything in between. Where do we even begin with all that?
Well, let's start at the beginning. Requirements engineering.
Okay.
Figuring out what the software needs to do, who's going to use it, all that.
Right, right.
And there's this framework, Elicitron.
Elicitron, yeah. Isn't that the one that uses, AI agents to simulate user behavior?
You got it.
It's like it can help us understand how people will actually use the software before we even write a single line of code.
Exactly. It gives you those valuable insights right from the start, which can really inform the whole design process.
That's super valuable, especially because, let's be honest, how often does software miss the mark? Like, it just doesn't work the way users actually need it to.
All the time.
What about, like, actually writing the code? Can these systems actually, generate code?
Oh, they can, but think of it more as a collaboration. The paper talks about these different roles for agents, like the orchestrator who manages everything,
Mhm.
the programmer who writes the initial code, and even a reviewer to check for quality and make sure it meets the requirements.
Wait a minute. So there's an AI code reviewer. I can
Yeah.
already see how many hours that could save.
Right.
But I could ask, does it actually produce, like, good code?
That's the question, isn't it? And that leads us to some really interesting case studies in this paper.
Case studies.
Yeah, they actually tested an LMA framework called ChatDev.
Chat dev. Okay.
Gave it the task of developing two classic games, Snake and Tetris.
Wait, so it actually built games, like working games. I'm picturing little AI agents with tiny keyboards trying to get those Tetris blocks to fall into place.
Well, the results were pretty surprising. For Snake, ChatDev managed to build a completely functional game
No way.
in 76 seconds.
76 seconds. That's like faster than it takes to order takeout. Are you serious?
Yeah, and for a cost of just zero point zero 0.01 nits.
So you're telling me we could be building games in minutes with these systems? What does that even mean for the future of software development?
It definitely opens up some exciting possibilities.
For sure.
However, the Tetris case, it was a different story.
Yeah.
ChatDev needed 10 tries to make a playable version, and even then, it was missing a core feature.
So still some kinks to work out.
Yeah.
But the fact that it could even try to build Tetris, that's pretty impressive. What does that tell us about, like, where these LMA systems are headed? What do they need to, really reach their full potential?
Well, that's where this research agenda comes in. This paper, it lays out two main phases for future development.
Two phases, huh?
Yeah. First, enhancing the capabilities of each individual agent,
Okay.
and then optimizing how those agents work together.
So, like, taking our AI dev team from a group of rock stars to a real band.
Exactly.
I like it. Tell me more about these phases.
All right, so phase one, it's all about making each agent smarter and more specialized.
More specialized. Okay.
We got to go beyond these general roles like programmer and create agents that are like experts in things like security, UI design, or even specific programming languages.
Yeah, that's like, if you could have an AI agent that's a security expert, right, auditing your code as you write it,
right.
that would be amazing. No more late nights trying to patch vulnerabilities.
Yeah.
But how do we get these agents to that, like, expert level?
Data. We need to train them on massive specialized data sets.
Okay, so it's like giving them years of experience in a specific field.
You got it. It's like targeted training. For example, let's say you have a security auditing agent. You'd train it on tons of data about known vulnerabilities, attack patterns, all those security best practices.
So they're not just learning to write code, they're learning how to think like a real security pro. That's pretty cool.
Yeah.
But even if you have all these specialized agents, they still have to, like, work together, right?
Right.
What's phase 2 about?
Phase two, that's all about optimizing that synergy.
Okay, synergy.
Making sure the communication between agents is smooth, figuring out the best way to divvy up tasks, and of course, how to bring human expertise into the mix.
So we're making sure our AI dev team isn't just a bunch of brilliant individuals, but like a real team, right?
Exactly.
Working together towards a common goal.
We can actually learn a lot from how human organizations work.
Okay.
The paper talks about applying concepts from agile methodologies, things like value stream mapping to these LMA systems.
So it's like creating an AI company.
Pretty much, yeah, with its own structure, communication protocols, all of that.
Wow. An AI company. That's kind of mind-blowing. I guess if we're really going to build complex software with AI, we have to think about, like, managing it the same way we manage human teams.
Exactly.
And just like with human teams, communication is key. The
Absolutely.
paper, it talks about developing more formal languages for communicating with these agents.
Right, because natural language, it can be, well, ambiguous.
Yeah, even for us humans, right?
Right.
Like playing a game of telephone.
Yeah.
The message changes as it goes around.
Exactly. So having a structured language just for AI communication, it makes a lot of sense.
It's almost like we're creating a whole new type of programming.
Right.
But instead of programming computers, we're programming AI agents.
That's a great way to put it.
And that could really help us understand how these agents, like, think, right? How they make decisions.
Yeah,
Make them more reliable, more predictable.
exactly.
But with all this talk about AI, let's not forget about, the human side of things.
Oh, of course not.
These systems they're designed to work with us, right?
Right.
Not replace us. How do we make sure that that collaboration is like smooth and effective? There's got to be some challenges there.
There definitely are. One of the biggest is figuring out how to integrate human expertise into that LMA workflow.
Okay.
We need clear guidelines, protocols for when humans need to step in, making sure developers are involved in the key decisions,
Hmm.
ethical considerations, the creative stuff.
So it's not just training the AI, it's training ourselves too
Yeah,
to work effectively with AI, a whole new kind of teamwork.
exactly. It's humans and AI as partners.
I like that.
And as these LMA systems, as they get more and more sophisticated, their ability to adapt is going to be crucial.
Adapt
We
to.
need them to adjust, their configurations, reallocate resources, even change those agent roles as the project changes.
So they need to be dynamic, responsive, like a good human team.
Exactly.
But let's not forget about one of the biggest things in any software project, right?
Mm.
Data security.
Oh, yeah, big one.
How do we make sure these systems are, handling sensitive information responsibly?
That's critical, especially as we move toward, multi-organizational development, where data is often siloed and there are all sorts of privacy regulations.
Well, it makes sense.
The paper, it actually highlights this as a major area for future research. We need robust mechanisms for data governance, access control, all of that.
So it's not just about building these powerful systems, it's about making sure they're trustworthy, ethical. We can't just throw all our data at an AI and hope for the best.
Exactly. We've got to build those safeguards in from the beginning, make sure they're not just efficient, but responsible.
This has been a really fascinating deep dive. We've covered the basics of LMA systems, their potential, the research agenda, even data security. Is there anything else in this paper that we should touch on?
There's one more thing.
Okay, what's that?
The paper, it kind of touches on this idea of potential threats to the validity of the research itself.
Threats to the research, like rogue AI agents trying to mess with the results or something.
No, not quite. It's more about the speed of things.
The speed.
Yeah, like this field is moving so fast, there's a real risk of missing important studies, overlooking stuff, just because the landscape is changing so rapidly.
So it's like trying to review a movie that's still being filmed. By the time you finish the review, the ending could be totally different.
Exactly. It's a real challenge for researchers.
For sure.
The paper really emphasizes how important it is to have, ongoing literature reviews and to combine that with rigorous experiments to make sure the research stays relevant, accurate.
So it's like constant reevaluation, adapting to the changes.
Yeah.
Researchers in this field, they got to be as agile as the systems they're studying.
Exactly. And that's what makes it so exciting. You're always learning, always pushing the boundaries.
It's been a real eye-opener, this whole conversation.
Yeah.
Before we wrap up, let's try to sum up some key takeaways for our listeners, especially, for folks who are thinking about how all of this could affect their own work.
Sounds good.
All right, so key takeaway number one, LMA systems, they're a big deal.
There.
A powerful new way to think about software development
For sure.
with the potential to, automate all those tedious tasks, make things more robust, more efficient, and maybe even help us build those super complex projects that seem impossible right now.
Yeah, all of that.
It's like giving developers a whole new set of superpowers.
Right.
But you've also been very clear that, these systems, they're still in those early stages.
Oh, yeah,
There's a lot of work to do before they live up to all the hype.
definitely. We still need to figure out how to improve those individual agents, how to make them collaborate better, how to handle data responsibly, and of course, how to make sure the research itself keeps pace with all the change.
So it's a long road ahead,
Mhm.
but it's a road that's it's full of possibility.
Absolutely.
And it's important to remember, right? This is about more than just automation.
It
It's
is.
about rethinking the whole process,
Yeah.
creating a more collaborative, more dynamic kind of environment where humans and AI can work together,
Yeah.
to build the software of the future.
That's exactly it.
That's what I find so fascinating about all of this. We're not just
Yeah.
talking about small improvements. It's a fundamental shift
Yeah.
in how we think about software, how we
Yeah.
design it,
Mm.
how we build it.
A whole new world.
And that brings up some big questions, right?
Yeah.
About the role of developers.
Oh, yeah. Big question.
As these LMA systems become more advanced, what happens to us? Do we become like architects orchestrating these complex systems of AI agents?
Right.
Or do we focus on the creative side, the strategic stuff, the ethical decisions? Or maybe there will be entirely new jobs, roles we haven't even thought of yet.
It's exciting to think about.
These are questions we all got to be thinking about. The future of software, it's happening right now, and it's up to us to shape it
Yeah.
responsibly, ethically.
Couldn't have said it better myself. The possibilities are out there, and it's going to be one heck of a ride.
On that note, I think we'll wrap up this episode of the Deep Dive. A huge thank you to our expert for taking us on this journey.
My pleasure. Always happy to talk about this stuff.
And to all of you listening, we encourage you to keep thinking about these questions, explore the research, and hey, maybe even contribute to this field. Who knows? You might be the one to write the next chapter in this whole LMA story. Until next time, keep diving deep.